see flat
Right.
sometimes not.
Okay, welcome back from our break again. This is 10th grade biology, for those of you who've forgotten your way out and back in. And we just talked about intro to genetics. And what we're going to do now is we're going to have a class discussion and then bring our lesson to a close. And on your guys' way out, I read your exit slips, admit exit slips that I gave you, just so we can I have an idea of where you guys stand with the material I just gave you. And so one of the goals of that is to ensure that I covered all the objectives for our lesson on Intro to Genetics, because our next chapter is going to be really heavy into this, how genetics works and how it's passed on to the next generation. So I want to make sure that you guys know that and answer any hanging questions you guys have, clarify main concepts, and this is all, again, all based on your admit exit slips. I also keep, from previous years of teaching, I keep these, so I can kind of get a popularity of what questions are coming asked. So I'm going to kind of follow that, and this year is kind of about the same thing as far as questions go. Kind of remind you of our objectives. We will be sure to cover all these again in our class discussion coming up. And these are in standard form, so. For class discussion today, I guess you guys are okay where you guys are at. So you guys are kind of spread out, but that's okay. And what we're going to do is, okay, so I gave you guys a handout. And on this handout, I posted some of the most popular questions that are commonly asked after going over this material. So what I want us to do is, stretch out, relax, and just kind of feel free to answer the questions however you think it comes to you. Don't worry about what the neighbor next to you is thinking. The whole idea of school is to encourage your own education. So, question 1, could I have somebody read that to the class? Ron, go ahead.
How do I inherit eye color? Because my eyes are blue and my parents are brown.
That's a good question. Thanks. From our lecture, what's the method of inheritance? Does anybody have an idea? How are traits passed on from one another? That's your cheat sheets. Anybody? Yeah.
Through your genes.
Right. And where do we get our genes from? Right. Very good. No, that's fine. That's fine. It's open discussion. So that's a good question, and when your parents, when their gametes are formed, the information is segregated out, and so your allelic pairs separate. So for eye color is pretty complicated. It actually is controlled by 3 different genes, but we're just gonna talk about one gene, and so you have your dad and your mom, and say your dad, the case was that they're both brown. Well, you have, for your brown eye color, we're going to say there's one gene, and we're going to say that one gene has two alleles. It has the brown, and then it has the blue. Alright? So, the parents are both brown. So we know by the idea of dominance that at least, and brown's the dominant color. So each parent both has to have at least the dominant version of the gene, or the allele. And then with their offspring was blue-eyed. So we know that to have blue eyes, it has to be recessive. And it has to be, it has to have both alleles have to be the recessive type, so it's homozygous recessive. If it had the dominant allele, what eye color would this be? Brown. Right. So, but how we know that their genes segregate when their gametes are made. So we know that each parent has to be a carrier for the blue gene, for the blue allele. So when they separate, some of their gametes are going to be brown. Some of their gametes are going to be the blue carrier. Same thing for over here. So we end up in your particular case, for those of you who have blue eyes, when your parents have brown eyes, each parent contributed their blue carrier, their blue recessive, or their recessive gene to make your eyes blue. This kind of answers some of our questions we had to ponder at the beginning of the lesson. One was how is it possible for these traits to be found on a person and their grandparents but not their parents? Well, again, going back to our parents here, their parents, your grandparents, had to have blue eyes, or had to be at least a carrier of the blue gene to pass it on to your parents. However, either your grandma or your grandfather, one of them, had to pass on, they could have both been carriers, they could have both be what we call heterozygous, meaning differing types among the same group. Or, they could have both, one of them could have been blue-eyed, and then alright. Because again, they're going to split, they're going to segregate their gamete, their gamete's going to segregate their alleles, and you're going to get one half. So that's why your grandma could have blue eyes, and your grandfather could have brown eyes. But when they had your dad, he got the brown eye gene from your grandfather and the blue eye gene from your grandma. So again, this is how your grandparents could show the same eye color as you, but your parents don't have it. So I hope that helps explain that a little bit. Question 2. Would someone want to read that for me? Go ahead, Haley.
I'm confused about what true breeding is.
Okay. Is anybody else confused about true breeding? Okay. By definition, it's an organism that when self-fertilized, or like in a plant, you self-pollinate it, it produces only offspring with the same traits. The alleles for these types of plants, again, are homozygous, meaning the same. So an example, we talked about Mendel and his pea plants. If he went up to his garden and he found round seeded peas, and then he went and found another plant that was wrinkled. If he self-pollinate those plants and they kept coming out wrinkled, then he knows that one came out wrinkled all the time, one came out round all the time. He knows he has a true breeding plant. So, and this also helps us kind of understand the next question. If someone wants to read that, go ahead. Yeah.
What is meant by a dominant allele and a recessive allele? What is the difference? How do they tell that one is dominant?
Very good question. How did we decide that brown eyes are the dominant? How do we decide that round peas are dominant to wrinkled peas? That's a good question. Well, what they do is they take, we have a round pea and we got a wrinkled pea. And the round, we're going to say big R is going to represent round and little r is going to represent wrinkled. Alright? And we're going to say these are true breeding, meaning that when I cross this, when I self-pollinate this, I get a round one, I get a round one, I get a round one, I get a round one. So, which means that its set of alleles for roundness are both dominant. So big R, big R. The wrinkled one, again, is a true breeding, homozygous dominant, or homozygous recessive, sorry, because wrinkled is the recessive allele. And so how do I determine which one's dominant? What I do is I cross them. When I pollinate a flower from the round peas with pollen from the wrinkled peas, whatever the resulting phenotype is, whatever it looks like, that's your dominant. So what you're going to get, again, you're going to get one half from each one. So the only possibilities here are dominants. The only possibilities here are recessives. So you're going to get one half of that from the one parent plant and then from the other parent plant. So when the resulting pea is round, then I know that my dominant trait is the round trait, not the wrinkled. Everyone kind of follow that a little bit? And then I think we covered that. You cross true breeding plants with different traits. Those traits were tied to the same attribute. So like you couldn't say that you want to use the same attribute, like round and wrinkled. You're not going to use round versus yellow. I mean that doesn't quite make a lot of sense. So you want when you're trying